And this time it's a different way of encoding stuff. I'm using, this is a full screen capture, not like just an audio capture. So after the class, I'm going to have to split it into 10-minute segments and then upload it to YouTube. And then after that, I have to string all the 10-minute clips together into a playlist. And then I'll send you guys a link to the playlist so that you can just play once and then it will just keep going and going and going. And I think with the playlist, you can also set it up to loop. So those of you with kids, you can also play it as a, to help your kids sleep just in case of any trouble. I'm almost guaranteeing it will work 100%. Even if your kid is not sleeping, you'll be sleeping, which is just as good, right? Your kid will be screaming like there's no tomorrow, and then you'll be going, yeah. That happens a lot. So anyway, we'll get started right away. And last time we were comparing my lightweight multi-threading kernel intended for a 16 megahertz 8-bit processor, and basically comparing and see how much that is similar to the p-thread concept, even though the two are obviously developed completely independently, and yet they have very similar concepts or similar features. So what I will do is I'm just going to finish this up really quickly, because the focus of this class is not a tiny little kernel, but a big kernel like the Linux kernel. And also thanks to Kevin, we found a bug in my code, and that's why you guys have until Wednesday to turn it in. Yeah, that was an embarrassing one.
Who's Kevin?
Kevin, jab him.
My pseudonym.
Real name code.
Alrighty.
What was the bug?
The bug was, I actually made a video clip of the bug. Let's see if I can.
Is loop and exit soon enough?
I think I'm putting it here, right there. Because it's easier to make a video clip out of it than to explain it on paper. Alright, this is a note to let you guys know about a problem in my solution of socket 3. On line 60, I use a variable called select result to keep track of how many file descriptors I have to go through the loop to scan for out of this particular select round. And this is selecting on read. Later on in a sub loop of this for loop, on line 95, I use exactly the same variable select result to store the result of another select call. This time it's selecting on write, in order for me to write to broadcast the same character to all three clients. So this will overwrite the variable used by the outer loop. And one of the symptoms this can cause is that the outer loop will not exit because select result is larger than what it should be, and as a result it will call read, this particular one, more times than it should, which in the end will block the call of read and causing issues with timing out when it really should not be timing out. So if you have experienced problems with read, either reading back 0 bytes or timing out, you want to fix this problem. This problem can be fixed quite easily by two means now that we know what the problem is. One is you can simply delete this portion of this assignment statement, because I don't really use the return value of the select call in the inner loop. The second thing you can do, if you want to keep track of the return value of select, which may not be a bad idea for debugging purposes, is to put an int right before select result here. That will define a local definition of select result. But that will also mean that you have to swap the order of these two statements, because in straight C, you cannot define a variable. So the easiest solution is to get rid of this portion of that line and not to store the return value of the second select when we.
And we can do more.
No Klingon?
No Klingon.
Oh, that might still be there.
Select on right. I apologize
Now,
for
nobody
this
can
mistake.
laugh.
I did not know about it. I was about it already. Thanks to Kevin, who actually found this problem. Now we know about it and we know how to get around this problem. I know some of you have been, your progress of this homework assignment has been stopped because of this particular problem. So what I would do is to postpone the deadline of this assignment until Wednesday. So you have until Wednesday to turn it in because of this particular issue. And good luck with the rest of the homework assignment and also studying for the final exam. I'll see you guys on Monday.
So there you have it. In case you didn't get the memo, let me send it.
So there's no class on Wednesday then? Or-
There's class on
that's
Wednesday.
for-
On Wednesday, we have the practice final. Yeah, don't miss
Yay.
that one. That's going to be important. But there will be no practical final. Yeah, there will be no practical questions in the final, which means there's no coding question, as far as you're concerned.
When is our final?
When is the final?
That's a good question.
I think it is in the notes, but let me just double check and make sure. The final exam is. Okay, where do I find that final exam thing? Calendar, final exam schedule. And then this is a morning class, Monday, Wednesday only, and we start from 10:30. So that will make it fit into this time slot. So the final is gonna be on May 19th, starting at 10:15, not 10:30, but 10:15 to 12:15 p.m. That's the time for the final exam. And I will also try to make sure that we can go to the lab for the final exam. So it will still be open book, open notes, open Google, except there's no practical questions. It will all be either multiple choice, calculated, or short answers. Yes?
Are we going to be covering anything between numbers 5 and 14, excluding 12? On the course Moodle thingy, chapter 5, Unix support for C programming, 6, C programming review, all the way up through 14, which is dynamic memory management.
There's
Excluding
no-
12, which we have Makefiles covered already.
You'll just be covering whatever we have talked about in this class. How's that?
So none of that stuff? None of that stuff?
Some of that stuff is assumed. So, any questions? I mean, I won't ask you any questions about dynamic memory access. Okay, management, stack, heap. Okay. So basically anything that I do not have notes for will not be a part of the exam. Okay. Any questions so far? Nope. No questions. Oh, if you guys have any questions, just go ahead and ask. I'm just trying to finish this up today. Last time we started to talk about this already, how to get the real-time kernel started. So with this one, we have an RTK initialize, which initializes the real-time kernel itself to basically have all the data structure related to threads pre-initialized, and it will also associate the main function or whoever is calling RTK initialize to the very first